In this video, we're going to learn how to calculate the wet bulb temperature from COAG-MET weather data, or if you're not using COAG-MET, any other type of hourly weather station data would be acceptable to calculate the wet bulb. Now remember, the wet bulb is different than the dew point temperature, and that there's no closed form algebraic solution to the wet bulb, so we have to use an iterative procedure. So that's what I'm going to show you in this video. So I've got started here with Microsoft Excel. I've got my hourly header information for the COAG-MET weather data network. I'm going to go over to the network and I'm going to get data from Fort Collins the first 3 days in July, and 2014 is what I'm going to use for this example. And I only want hourly information. Submit that. Hit Control A, Control C, back to the spreadsheet, paste it in the upper left hand corner, cell A2, hit Control V. Now remember, we've got to spread that out over the columns. Go to Data, Text to Columns. It's delineated, so we want to go here to Tab and comma, Finish, and now we can see all of our information. Starting on July 1 and going down through the first 3 days of July. Now that we have our data, we're ready to try to approximate the wet bulb. Okay, so the good way to start this is to take a quick look at the theory first. We had a handout on this called Calculating the Wet Bulb. We see the psychrometric formula here. What we do, I'm not going to go through it in detail, is use the definition of the slope of the saturation vapor curve at dew point and wet bulb location. And with a little bit of algebra, you can derive this equation, which says we can estimate the wet bulb as a function of air temperature, dew point temperature, the psychrometric constant, and the slope of the saturation vapor pressure curve. The trick is that this slope of the slope as computed here should be at the average temperature of the wet bulb and the dew point temp. Since we don't really know the wet bulb temperature a priori, we have to iterate a little bit to get this to work. And that's what I'm about to show you here. It's not too hard in Microsoft Excel. So back to our spreadsheet. The first thing I'm going to do is insert some columns, starting in column F, and I'm going to insert 7 columns total just to make this easier. So 1, 2, 3, 4, 5, 6, 7. If you recall, to do this problem, we need the psychrometric constant. That's a function of pressure. So we're going to need atmospheric pressure. We're going to need the psychrometric constant. We're going to need to calculate the dew point temperature. We're going to need to calculate the average of the wet bulb and the dew point temperature, which I'm just going to abbreviate as follows. We're going to need to get the saturation vapor pressure at that average. We're going to need to calculate delta, or the slope of the saturation vapor pressure curve, and then finally we're going to need to calculate the wet bulb. Okay, so we have to add 7 columns here to work this problem. Let's start with pressure. We know we can estimate pressure from elevation above sea level, so you could just type in the pressure if you know what the pressure at your location is, but let's put in the formula. It equals 101.3 times exp. And here's where I put in the elevation. So in this example, my elevation is 1,525 meters. If you were at a different location, you would put in your elevation, again in meters. And we can see that we get about 84 kilopascals. That's what we would expect for our elevation here in Colorado. The psychometric constant now can be approximated from that pressure. So we say it's equal to 0.000665 times the pressure. And we get about 0.056, which is pretty typical for our elevation. Now we're ready to approximate the dew point temperature. Okay, there's formulas for that in your textbook. Again, it's I believe it's equation 3.14 in the Campbell and Norman textbook. This is going to be a function of vapor pressure, which we have over in column E. I'm going to use the Buck 1981 coefficients. Now I'm going to use the vapor pressure. Okay, so that gave us the dew point temperature, about 4 degrees. All right, seems kind of low, but again, it's only 13 degrees outdoors at the moment. So there's our approximation of dew point temperature. All right. Our next column is to calculate the average of the wet bulb temperature and the dew point temperature. Now we don't know the wet bulb temperature yet, but we can go ahead and put it in the formula. We can say equals to T wet plus TW divided by 2. And it just put in the assumed value, an average value of 0 for that at this point. And now we need to calculate the saturation vapor pressure at this new at this average temperature, and we just use the regular Teton's formula for that. Okay, there we go. And now we're ready to calculate the slope of the saturation vapor pressure curve. And that's going to use at this average condition. So it's going to use both I2 and J2 in this example. That formula is also in the textbook and is a variant of Teton's equation. Okay, and then finally we're ready to calculate the wet bulb temperature. And again, that's that formula that's a function of T wet, T air, a calculation of T dew, T air, delta, and the psychometric constant. Okay, and we can see that right now it's kicking out a value of 0, which we know is not correct. So one of the things that we have to do is go back over here and modify the default settings for Microsoft Excel. So you go to File, Options, Formulas, and you have to enable iterative calculation right here. Okay, and notice as soon as I did that, all of these numbers changed, all here in the block. Went from 0 to 8.67. So let's look at that again. Go over here to File, Options, Formulas, and you have to enable iterative calculation. Now, I set my maximum iterations to 10. I think the default is much higher than that, but 10 is plenty, okay, for this type of problem. So make sure you do that, and you should see them change and iterate to solution. We can check this really quick. If we look at our conditions here, it's got an air temperature of 13 degrees, a relative humidity of 53.4%. Here's our atmospheric pressure. And we can go over to NOAA's website and check this really quick. So I'm going to go to the NOAA dew point calculator. And I've actually put the data in here so you can see it. But here I put in the air temperature in Celsius. I put in the relative humidity in percent. And I put in our pressure in millibars. Millibars is just the kilopascals times 10. So these three numbers, again, are coming from our spreadsheet: 13.73, 53.4, and 84.11. Those three numbers. And we have them over here now in our, and we ask it to convert, and we look at the results here. It says the wet bulb is 8.66 degrees, and you can see that's exactly what we got, 8.67. Okay. Now once you have those groups of cells set up and ready, you can go in here now, highlight these, and click on them, and it'll go ahead and calculate the dew point for the rest of them. Now remember, don't remember if I showed it, but I'd already done that for pressure, cycron, and T-dew. These first three do not have anything to do with the iteration. So once you get those three done, you can click those and fill those in. And then the second four, this group right here is the ones that iterate. Now that we have the dew point temperature, we can plot it up. Let's plot time as our x-axis, temperature, T-dew, and T-wet. Okay, and then I just say insert scatter plot. There we have it. Let's move it up, right click, move chart, new sheet. I'm going to call it T-air, T-dew, and T-wet. And here's one that I've already formatted so you can look at it. But here's our air temperature data, the blue. Our wet bulb temperature that we calculated with our iterative solution shows more of a diurnal pattern. And then finally wet bulb, which doesn't show much of a diurnal pattern at all, just a gradually increasing trend. This is the actual amount of water vapor in the air. One thing that's kind of interesting is to note, right pre-dawn, right before the sun comes up, a lot of the time you see all three temperatures sort of converge on a single point. That's a very common phenomena. And the more humid the climate is, the more common this occurs. If it's a very arid climate, we're pretty arid, and so some nights it doesn't kind of converge on that single point like we see here. But it's a very interesting process. So anyway, this is completes the demonstration of how to calculate the wet bulb temperature from spreadsheet data, and can come in really handy in certain cases where the wet bulb might be needed for some type of a calculation, and doesn't require you to write some type of subroutine in Visual Basic or write a special macro. You can do it using your normal Excel skills. The key to the whole thing is knowing that you can go over here to options and formulas and allow this iterative calculation. It's really the sort of the key thing to learn about.